Well, good day. We are going to continue with the paper 2, 2003, and we are with question 8. We're busy with question 8. I'm given these number, square, cube. The number is 3, the square of 3 is 9, and the cube of 3 would give me 27. Now I'm asked to find these other values. Okay, so to find the square of 21, I need to take the square root of 21, and if I do that, I get 11. Okay, 11 cubed would give me 1331. So the answer there would be 11 cubed. Okay, now this one, 2744, if I take the cubic root of it, I will get the cubic root of 2744. Would give me my answer of 14. And if I take this 14 and I square it, I will get 196, and that's my second answer. Okay, so the same thing here. If I take the cubic root of negative 343, I will get negative 7. If I take that negative 7 and I square it, I should get 49, and that's the answer for question 8. I think this is a very, very easy little problem. Probably not something that you can expect in the exam. Okay, so I'm going to show you the next question and see if you can make up slide of it. So question 9, they say find the gradient of this line A and B. And to find the gradient of a line, we can do two things. I can actually count it delta y over delta x, and we move one space up in the y-axis and 1, 2, 3, 4, 5, 6 spaces across in the x-axis, and that would give us the answer. So we know that the gradient is delta y over delta x. We're busy with question 9a, and I move up one space in the y direction, and I move 6 spaces across in the x direction. Thus my gradient of line AB, m of AB, would be 1 over 6. Okay, very, very nice and easy little sum there. Then the next bit, they ask us calculate the angle that AB makes with the x-axis. Okay, now something interesting is if I extend that line AB, so AB is lying here, A and B. If I extend it, the angle will stay exactly the same. So that would be angle theta. And we want to find what would this angle be compared to the x-axis. Now, to make life for me a lot simpler, I'm going to move this axis up. And I'm going to say that's theta there. The reason is I already know that I can use my Pythagorean of I can use my trigonometry identities. This distance over here I know is 6. This distance over there I know is 1. Okay, and I think I'm going to run into I've got a little bit more space there. Okay, so let's go with SOHCAHTOA. I don't have an hypotenuse. I can use the opposite over the adjacent, so tan. So tan of theta is opposite 1 over 6. So tan inverse of 1 over 6 would give me theta. And if I plug that into my calculator, let's quickly see. Tan inverse of 1 over 6, and that would give me 9.46 degrees or 9.5 degrees, correct to the 1 decimal place as I need. Good, so that was question 9. Okay, work out as a single fraction, question 10. And we have 2 and x minus 3 minus 1 over x plus 4. And I've got to write that as a single fraction. While my denominators have to be the same. So x negative 3, x plus 4, the negatives stay there. the 2 and the 1 in my numerator stay. What did I have to multiply this fraction to have x minus 3 and x plus 4 in the denominator? It would be x plus 4. Okay. What did I have to multiply this fraction to have x minus 3 and x plus 4 in the denominator? Well, the answer is x negative 3. Okay, now we need to simplify this. So x negative 3, x plus 4 in my denominator stays there. I distribute, so that would give me 2x plus 8 minus x plus 3. A negative times a negative would give me a positive. And let's do that. X negative 3, x plus 4 stay in the denominator. It doesn't change. That would give me x plus 11. And that's as a single fraction as far as we can go. Okay, good. So the next one is right. I'm going to move on to question 12. We'll come back to question 11 in a tick. I have a circle with O as the diameter and a point B lying there, and the point E lying there, the point D lying over there. And the point C there. Okay, this is 2P, that one is Q, that one is 5Q, that one is 3P. Okay, now let's have a look. If I have as AOC is the diameter of a circle, it all immediately I know that the angle subtended at the center of a circle would be twice as large as the angle at the circumference of a circle. This is 180 degrees, and therefore that one would be 90 degrees. So I draw that in immediately in your sketch. Okay, then I also have to note that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So Q plus 5Q would be equal to 180 degrees. Okay, so we have two things that we have to find. We have to find P and we have to find Q. So P, to find P, we can use the interior of angles of a triangle add up to 180. So 2P plus 3P would plus 90 would give us 180, and that give us 5P would be 90, and P, the value of P, if I do use my calculator, would give me 18 degrees. Now similarly, we said the opposite angles of a cyclic quadrilateral add up to 180. This is a cyclic quadrilateral A, C, D, E. It's 4 sides on the vertices of a circle, and we know that Q plus 5Q would give us 180 degrees. Okay, so 6Q equals 180. That means Q must be equal to 30 degrees. And we are done with this question 12. Okay, let's move on. Question 13. Question 13 is a histogram. The frequency, density, and age. It's not well printed even on my sketch, so I hope it will be all okay there to do it with you guys. Okay, so my first group, I have age and the number of patients, and 0 to 10, and there's 300, 10 to 30, and we have 600. Then from 50 to 60, I don't have any values. 60 to 100, I have 880. Okay, so then they ask us complete the following. A, 1 centimeter squared represents how much? Okay, so before I can start there, I've got to think about it. what would be my frequency density? 300. So I need to have some base. I need to know what would be these values that are not filled in here on the side. Okay, so I know one thing. Frequency density would be frequency over class width. Okay, so my frequency density, that's what I want to know. And I know the frequency for my first value, it is 300. I know the class width, it is 10. So I can find the frequency density is 50. That means for this little block here, that little block there, that you can sort of see is printed, that frequency density must be 50. So 10, 20, 50. Do you agree with me that that little line would be 50 there? Okay, this little block there would be 50 there. Okay, good. So if I've established that, it is quite easy then to think what would be 1 centimeter cubed. If I look at this as a grid that's 1 centimeter by 1 centimeter, that would give me that little grid there, that is 10, and then that one is 10 up. So the centimeter, the 1 centimeter cubed would represent how many? So let's go frequency density equals, sorry, let me just do that. Frequency, that would give us, we don't know, over class width, that frequency class width, we'll fill in the values now. So that would give us frequency density 10. Frequency is the one that we want to find. Class width is also 10. So we can find frequency as 100. Okay. So 1 centimeter squared represents 100 patients for the doctors. Okay, use the histogram to fill in the table, the blank in the table. Okay, so that is the 50 to the 60 year age gap. And if I look at that, well, we have to look at the value there. So let's go again. Frequency density equals frequency over class width. Okay, so the third one, what I could see here, it's 8, so 60 to 100 is that little block there. Then that would be the block that we are talking about, that's 30 to 60. It is up to 40 in my frequency density, and the 10, 20, 50 wide. Okay, so frequency, we don't know what it is. I know the frequency density is 40, my class width is 50, so my frequency can be 1200. Okay, so that would be question B here, 13B. Okay, so C is draw the two missing rectangles to complete the histogram. And well, let's quickly just work out what would be their frequency density. It is that 600 frequency density would be their 600 frequency over their class width, that is 20, and that should give us an answer of 30. Okay, and for the next one, we have the frequency density would be frequency, that's 880, sorry, over 40. And if I do the calculations, that should give me 22. So your little block there should be 30 high, and 20 across. So that's 20, and that one would be 30. The next one would be 40 across and only 22. And that would be the histogram blocks that we will draw in on our graph. Okay, good. Let's carry on. Okay, question 13. Okay, it seems like we need to cut the video again here and carry on with it in the next one. Thank you.